Hello, welcome to section 3.3, where we're going to look at graphing parabolas. Part 1 here, and we're just going to introduce some of the vocabulary that we use to describe parabolas, such as the vertex. The vertex is the highest or lowest point on the parabola, such as with this parabola, it's right here. With this other parabola, the vertex is the name of that point right there. And we'll go over how to find it later. The axis of symmetry is this vertical line through the vertex, just the line that goes up and down there. And there's also the x and y intercepts that you want to describe when you're talking about the graph of something. So here's an example of that stuff. So when you've got y equals negative 1/2 x, negative 0.5x squared, plus 1x plus 1.5, then the graph will look like this. And let's look at where the vertex is. The vertex is at the point 1, 2 here. The axis of symmetry is this vertical line here. That looks like the line x equals 1. If we want to find the y-intercept, the easiest way to find the y-intercept is it looks like it's approximately 1.5 there. It looks like you have the point 0, 1.5. You could check that though by just plugging it into the formula, plugging in x equals 0, because at the point on the y-intercept of any graph, you're always going to have x equals 0. And here's the work just checking that you get the point x equals 0, y is 1.5. And then it looks like the x-intercepts are negative 1, 0 and 3, 0. The way you could find that if you didn't have them here is you could solve the equation 0 equals all of this stuff. And here's what the work to do that would look like if you didn't have the graph right in front of you. You would set y equal to 0 to find the x-intercept and then solve this equation. It's a little tricky to factor out that negative 0.5 there, but this is what it would look like. You can check that by distributing the negative 0.5 in there and making sure you get this. But anyways, that gives you x equals 3 and x equals negative 1. So that's the basic way you can use the equation or the graph to describe the main features of it. Here's another one. By the way, these graphs that I'm looking at, I got them from a GeoGebra applet thing I made that lets you mess with the values of A and values of B and values of C and see how they change the graph. You're going to be able to access this on the site from a link that I'll give you in the homeworkitems.pdf file. But it's fun to mess around with this and see how it changes things. So anyways, let's just identify the vertex of this. So one way you can find the vertex is it looks like it's negative 1.5 here, but how would you be sure? How do you know it's not like negative 1.4 or negative 1.6? One way you can tell is by saying, well, because of the way a parabola is symmetrical, we can tell it's going to be halfway between the x-intercepts. So you can first identify the x-intercepts as 0 and negative 3, and then you can say that the x-coordinate of the vertex is going to be the average of these two x values, because it has to be halfway between them because of the way a parabola is symmetrical. So, in other words, the x-coordinate of that vertex should be halfway between 0 and negative 3. And one way you could find that is by getting the average of 0 and negative 3. So the formula for the average is going to be where you just add them up, 0 plus negative 3, and then divide that by 2, and you'll find the number halfway between them, That gives you -3/2 or -1.5. So yeah, that way you can be pretty sure that it is exactly -1.5 and not -1.4 or -1.6. And then once you have that and you want to know the y coordinate, it's a little hard to tell from right here exactly what that is. Is that -2.3, -2.2? I don't know. Let's actually figure it out by taking this x coordinate of the vertex and plugging it in here. And so I just took the x coordinate of this point, plugged it into the equation to find what y should be, and I got -2.25. So it wasn't quite either of these, it was halfway between those. And so we can say the vertex is -1.5 is the x coordinate, and the y coordinate is -2.25. Okay, and I didn't say what the y-intercept is before, but I might as well right now. It's also the same as the x-intercept. It's 0, 0. So that point is both the x-intercept and the y-intercept. So anyways, that's another way to think about the vertex is halfway between the two x-intercepts to get the x-coordinate, and then the y-coordinate is the result of plugging that number in.